Okay, this is a pretty classic problem in electrostatics. What we're given is Q1 and Q2, two charges, and we're given the distance between them, which I've called D, and we're asked to find the point in between them where the fields due to these two charges will cancel. I should point out that Q1 and Q2 are going to be the same sign. You could hopefully convince yourself that if one of them is negative and one of them is positive, there will never be a point in between them where the fields will cancel. You can think about the direction of the electric field associated with positive and negative charges, and hopefully convince yourself that that's true. So what we're saying is that there's some point in here, some arbitrary point, where the summation of the fields is exactly 0. And I've intentionally put this point not at the center, because if Q1 and Q2 have different magnitudes, then it won't be at the exact center. So just as a little preliminary work, let me point out that the field from Q1 at that point is going in this direction. The field from Q2 at that point is going in this direction, assuming that they're both positive. Assuming Q1 and Q2 are positive charges, I should say. So I can see that directionally one of these is going to be negative. The field, that is, one of them is going to be positive, and they're going to cancel. So all I'm going to concern myself with here are the magnitudes. So the first thing I'm going to do is write down the electric field equations. E1 is going to be the field associated with Q1. K Q1 over R squared. Let me point out what that is. R is going to be this distance right here. And I'll subscript that as R1. We're also going to have a distance here. It should be R2. Now, that's a little problematic, right? R1 is the distance that I'm really interested in. I'm interested in how far it is from the origin, which I've set up the coordinate system in this manner to make that calculation a little easier. So R2 presents a little bit of a problem because it's an unknown, and I'm going to have to find another equation to solve it, for it. As it turns out, that equation is really easy, though. Notice we're given the distance from Q1 to Q2 is D. So the other equation I can find is R2 is just equal to D minus R1. If you have trouble seeing that, go ahead and pause the video and think about it. So you can convince yourself of that. So if that's the case, I'm going to relabel that as D minus R, and I'm just going to go ahead and drop subscript to make the notation a little less cumbersome. Okay, so I've got the distance R is what I'm looking for. I've got D minus R, which is the distance from the observation point to Q2, and I think I'm in good shape. So I'm going to write down the electric field now to Q2. I've got K Q2 over D minus R squared. And I could perform some algebraic wizardry here and come up with an answer. I think if it's allowed for you to do it, and the person I'm making this video for can do it, it's easier to solve this graphically. So what I'm going to do is I'm going to go to my calculator, and I'm going to go to a different sheet, and in my y equals area, I'm going to graph y1 equals 2, and I'm going to actually put in the numbers here. Oh, I would in my calculator. I'm going to write them down so I don't have K memorized. K Q1 over X squared, where y1 here is going to function as my electric field, and X here is going to function as my R squared. Right? So now I'm going to go down to the next line. I'm going to graph y2 equal to K. Again, I would put in that number. Q2, I put in that number, divided by D, and I put in that number, minus X, quantity squared. And so I'm writing C symbolically because I haven't specified charges for Q1 and Q2, or I haven't specified the distance D, and I don't have K memorized. But when I type into my calculator, the only variable I would have there is X. The others would be actual numbers to get the answer to the question you're looking for. And then I would graph these simultaneously. What you're going to see is that y1 is going to look somewhat like this. y2 is going to look somewhat like this. And there's going to be an intersection intersection point, which you can find using your intersection or your trace command on your calculator. I think that's the easiest way to do this problem. If you have any questions, leave them in the comments and I'll get to them.